Okay, number 51 here in section 3.7 is a tough problem. Y is equal to the square root of sine of x times cosine of x. The very first thing, and I've said this to you guys many, many times, I'm going to keep saying it till we're all blue in the face, you really don't want to try to differentiate with radicals. It is always a good idea to rewrite those radicals in an exponent form. So this is sine of x times cosine of x, all raised to the 1/2 power. So here we go, guys. We're going to find our derivative here by taking what? Well, the last thing I see happening in this function is the 1/2 power. That means I'm going to use the power rule first and foremost. So the derivative of something, don't worry about what it is right now, something to the 1/2 power is 1/2 times the same base. It does not change. Sine of x times cosine of x. And we drop our power by 1, so we now have negative 1/2 for the exponent. But wait, there's more, times the derivative within. And so whatever that base was, sometimes it's very simple, in this case it's a little complicated, sine of x times cosine of x, whatever that base is, we now need to multiply by the derivative of that base. And this is where people sometimes get into trouble. To take the derivative of this base is going to require the product rule. Sine of x multiplied by cosine of x. Since the product rule gives me a binomial, I think parentheses here are a good idea. And here we go. First factor is sine of x multiplied by the derivative of the second factor. Derivative of cosine of x is sine of x. Got it. And then plus the second factor, which is a cosine of x, multiplied by the derivative of the first. Derivative of sine of x is a negative cosine of x. So I'll cram a negative cosine of x in there, close the parenthesis, close the bracket, and that takes care of the product rule now. So my derivative is complete. Now at this point, it's just a question of simplifying this mess. And what do we see here, guys? I got the 1/2 out in front, and I've got this quantity, sine of x times cosine of x, to the negative 1/2 power. That tells me I'm going to want to write this as a fraction. So the 1/2 would give me a 1 on the top and a 2 on the bottom. I'll leave the 1 out for now. Then sine of x cosine of x to the negative 1/2 power becomes a square root down in the denominator. So square root of sine of x times cosine of x. And then what happens with all of this? That the derivative within gets multiplied. It goes to the numerator. So sine of x times sine of x is going to be sine squared of x. And then plus cosine of x times a negative cosine of x is going to be a minus cosine squared of x. And it would have been really cool, you guys, if that were a plus right there, because then sine squared of x plus cosine squared of x would have just equaled 1, and the answer would have been a lot nicer. But unfortunately, we can't just change that around, as it were, so that is our answer that we came up with here for problem number 51. Actually, I'm back. As I'm looking at the solutions manual for 51 right there, guys, they have got something written a little bit different. They used a double angle formula here, guys, that involves you knowing something from pre-calc about the sine of 2x here being equal to, oh boy, and I've always got to remember that right there. Sine of 2x is equal to 2 sine of x times cosine of x. Now, under no circumstances am I requiring you guys to know this or have it memorized, nor am I going to have you use it either. So for our purposes right here, guys, I'm perfectly fine with the answer that we had there in blue. They took some time to rewrite this original expression then as y equals the square root of, and they took this red equation that I have at the bottom and just divided the 2 out on both sides. So they made this now a 1/2 sine of x, and that equaled the sine of x cosine of x from there. And they worked that route then, everybody, to try to figure out their derivative. And I'm going to spare you the long, boring explanation. This answer that we came up with is mathematically equivalent to their expression, but I'm sure some of you guys are worried about that. I'm not going to make you do it their way. This answer that we had right here is perfectly fine for problem number 51.